Mathematics, Advanced Subsidiary Level, Paper 2, 2022, Part 5. Question number 7. Show that cosec 2x plus cot 2x is equal to cot x. Okay, this is an identity, a trigonometric identity. Now, I will take you to the formula sheet, but cosec will not be there. You will find that on, if you look in the textbook at the summary on page 218, then you will see that cosec will be always 1 over sin. So if I'm going to write that one, I'm going to say 1 over sin and keep the 2x. Okay. Now, the same with cot 2x. You will just find that cot, it's also there on page 218, is cos theta. So cos is on top over sin 2x. Okay. Now, if I'm going to do this, do you see that the denominators are the same? This is the left-hand side. Okay. So I'm going to have sin 2x, and I'm going to have 1 plus cos 2x. Okay. Now, I can go and I can change this double angles. Now, I can see it both on the formula sheet. Let me just take you, but I will also take you to the page in the textbook. But I think that this will help me here. So if I look in for the double angles, I can see, do you see cos 2? It's 2 cos squared a minus 1. But sin, do you see sin? Sin, it's going to be 2 sin a cos a. Okay, so the formula sheet can help you there to break that double angles up. So let's just go back. But as I said, I also want to tell you in the textbook, because there it's also always integration. Just go to integration. It's chapter 12 in my textbook. And you see also the nice formula sheets, and you see all, no, that's integration. It's chapter 10. Sorry. As soon as I see it, I realize, oh, it's chapter 10. So that's the chapter 10. And you see all the formulas there on page 469. Page 469, and that's the double angles. Just remember, cos is having more than one option. So I am going to search for the option that I think will work best in this example, which I showed you on the formula sheet. Okay, so now I'm just going to go and I'm going to substitute that. So it's 1, let's just get my color correct. So it's 1 plus, and now it's 2 cos squared x minus 1. I'm just substituting that. And don't forget that this sin 2x, it's going to be 2 sin x. And don't work with the a's on the formula sheet. No, the question is x. So x, I just substitute the a with an x. So, and it's cos x. Okay, now what do you see happen? That cancel out. So I'm ending with 2, and I have cos x. And don't forget, that's actually just meaning I multiply this. And then it's 2 sin x cos x. And then I just cancel that, and the 2 cancel, and I'm left with cos x over sin x. And then that will be equal to cot x. So the left-hand side is equal to the right-hand side. As easy as that. Really not that difficult. Okay. I usually, some questions I do it, some don't, but I think for now, for this last part, I'm going to do it now. Just go quickly and rather just do the example afterwards. So they say poorly answered. Many candidates did not seem to be familiar with the concept of double angles. Commonly wrong notation seen was 1 over sin. No. That 2x go with the sin or something like that. It seems as they have the misconception that cosec 2x means that cosec times 2x. No, it's a unit. Many candidates did not know that the basic identities that they needed to study in order to convert cosec 2x to sin 2x and cot 2x to tan 2x. The variables were also very often changed from x to a, like on the formula sheet. No, which causes candidates to lose all their marks in the question. So they are very strict. Make sure you keep with what the question is saying. It is advisable that candidates should be taught to convert all the unknowns to sin x and cos x only when they attempt to simplify trigonometrical identities. The candidates who use the conversion cot 1 generally struggle to prove the identity. So to go to cos and sin, it's not always the easiest route, but it's usually going to bring you to the answer. Okay, let's go back to the question, the last question on that, question 7, the B part. Okay, no, I'm too far. So let's just find B. There. Oh, and I see this is integration. So look for a key that you almost take your mind to that chapter. So I see, oh, this is trigonometry. I see integration. This is further integration with trigonometry. So if I must give you a page, I will say page 5 to 9. That will be very nice to check. And I even wrote here page 5 to 6, example 11, to check. Okay, so basically I'm just going to now find this, and I start. So I say, now people, they didn't say hinge, but actually that's what they meant, and I'll show you now. You must always look if A cannot help you. It's a lot of times they let you do A to help you. And in this case, it's going to be again like this. So I have to make it a bit smaller that you can see A. Okay. So if you look at A, you will see, and now compare this with this. Do you see? So basically you see instead of 2x, it's exactly the same, the words, but there is just 4x. So I'm going to make this statement. I'm going to say, you can even say it like this. So from A, if cosec 2x, I didn't integrate yet, I'm getting ready for integration. Cot 2x is equal or identity to cot x. Then cosec 4x plus cot 4x will be equal, and now look, to cot 2x because it's double. Did you see that? So basically, and I didn't integrate yet, I'm going to change this to, I still keep my integration, and in the place of this yellow, I'm going to write cot 2x and keep your x. And now I'm going to first simplify it before I integrate. I'm not integrating yet. So if I have sin 2x over 1 multiply cos 2x over sin 2x, and you can still write every time dx. It's good to keep always form. Okay, so that cancel out. So I'm sitting with the integration of cos 2x dx. Okay, and now for the first time I'm going to integrate, and if I integrate this, and now let's see if we can find that rule on the formula sheet. Otherwise we go to integration to find that rule. Now I think what is going to happen is you will just see that cos go to sin, which is correct, but you will not see that extra, and that, I think that's why I wrote there page 5 to 6. Let's just go there. I just want to show you page 5 to 6 to show you what rule I'm working with. Page 5 to 6. Okay, so page 5 to 6, and I'm going to just show you here that if I'm looking at that, it's saying like, can I just show you on page 5 to 6? Okay, it's saying to you, okay, because this is cos. So it's saying if you just have cos, which is on the formulas here, then you will have sin x plus c. But it's going further. If you have cos and you have ax plus b dx, that will be equal to 1 over a. It's integration. It's not differentiation. So 1 over a sin, and then the bracket as it is, whatever, and then plus c. Okay, and that is the statement that I'm going to work with, that 2. That's the value of a. So basically, I'm just going to say it's going to be a half, because it's 1 over a, and then it's sin, and then you keep the 2x, and please don't forget to, it's open. It's not, there's not boundaries, so to say plus c, and that's the answer. Okay, let's see what the exam report is saying to you. So let's just go 7b, and what do they say? Extremely poorly answered. Very few candidates realize that part A of this question should have helped them to simplify the given expression to a single term that could be integrated. The angle of cosec 4x plus cot 4x was double of those given in part A, with the result that it could be replaced by cot 2x from the identity that was proven already. Many candidates did not realize that they had to change the given expression to a single term first and then attempt to integrate the terms separately. Teachers should take care to explain to candidates that there is not product, quotient, or chain rules that they can use in integration. That is all for differentiation. And this is very important when you come to the end of the syllabus, is that there's certain mind things that you have to just keep in your mind. So you're not going to find a product or a quotient rule in this syllabus, and you're not going to find it in integration. Okay, and then the answers, can I just show you the answers? Okay, so basically there is just, there was the A, and then this one was just the plus C. So, and there they say C, and they gave you the 2 marks. Okay, so it was really not that difficult if you used the part A. Question number 8. It is given that, and then the integral 2a and a, 3 over 3x minus 5 dx equals ln 13 over 4. Find the value of the positive constant a. Okay, you will find an example that will help you in the AS-Level Mathematics textbook on page 523. Okay, now let's start first with the integration. Now, if I write that integration, and it's 2, first just the left-hand side, and it's a, and it's 3 over 3x minus 5. Let's just first integrate that side. Now, I can take you to the formula sheet to see that the integration, but it's always the simple one that they put there. And then it makes it this integration, I saw it. So the simple one will just be saying if it's 1 over x, it's ln x plus c. But if you go, and I'm going to go back. Okay, let's just go back. If you go, and you go back to page, in my textbook, if you look at the end of chapter 12, on page 545, so page 545, I think there it's very nice, and it's far more clear that I wrote it there, and I said, if you have 1 over ax plus b, and you have dx, then it's 1 over a, and then it's ln, and then it's ax plus b plus c. Okay, so that will help you a lot, what you see on that page. So let's just do it then. Then let's just say, okay, it's going to be, keep the 3 on top, and it's 3, and what that is also a 3, so it's 3 multiply 1 over 3, but it's 3 over 3, and then ln, and then just, it's going to be just that bracket. Let's just write the bracket down. So just that bracket. Did you see? So ln 3x minus 5. And then the boundaries will be 2a, and it will be a. Okay, now I do substitution. So just the left-hand side. So then this is going to become 1. So it's ln, and then it's 2a minus 5, okay, and then it's minus ln, and then it is 3a minus 5. Okay, now if I simplify this, I'm going to get ln 6a minus 5 minus ln 3a minus 5. Now, don't forget the log rules. I'm busy with logs, lins. So what if it's subtraction? If I want to make it one term, I say ln 6a minus 5. I go in division, 3a minus 5. So there was two words. Now it's just one. But now that is equal to that. So to ln 13 over 4. Now, our equation works like this. I see ln on both sides. So what can I do? I can eliminate it. So I'm having 6a minus 5, or take it away. That is a better word. And this is 13 over 4. And now it's simple algebra. So I just put the brackets and I multiply over cross. So I get 13, 3a minus 5 is equal to 4, 6a minus 5. And I move up and I multiply and I get 39a minus 65 is equal to 24a minus 20. So 39a minus 24a is equal to 65 minus 20. So I'm going to get 15a is equal to 45. And I'm going to divide by 15 and I'm going to divide by 15. And I get that the value of a is equal to 3. And you can check that is a positive constant a. That's really, really, just know your rules. Okay. Now let's go to the exam. I'm going to the report. So basically, I'm just going to check for number 8. That was 7. Okay, let's just go to 8 and see what they say. Okay, so it's moderately answered. Not so bad. It was sadly seen that many candidates struggle to answer this question successfully, though a very similar question was asked in the final examination of 2021. I think that's that question too. Many candidates did not realize that the expression will integrate to ln, so you didn't know the rule. Especially that summaries at the end of the chapters, memorize that. Okay, I always say you memorize so many things in biology, but when it comes to just memorizing a few things in maths, then you are a little bit lazy to do that. So don't be lazy, memorize it. So more care should be taken in the teaching of integration in theme 2 to make good candidates aware when the expression integrates to a ln and when not. Okay, so know your rules. It should be noted that the use of brackets in this question was of extreme importance. It was often wrongly seen that ln, so you have to put that real, it was simplified. Okay. The use of log laws was also poorly executed. Okay. It was too often seen that this is wrongly written out. Only one ln word with the division, 2 with the subtraction instead of this. It's just the formal way. Just concentrate on that, especially in this level of mathematics. So, or actually always, but very important that the formal way of writing is important in this level. As a trigonometry, many candidates did not understand the correct in ln. They treated it as a variable that can be divided by. The result is another common mistake where. So, as I said, this is definitely not mathematically correct to this. Okay, so very important to take note. So this and this is equal, wrongly simplify to this. Okay, that means if you didn't go use the rules, the laws of logs. Many candidates did not realize that ln is just a log with a different base, a base of e, and struggle to apply their basic knowledge of the ordinary level syllabus correctly. So even this logarithms is in ordinary level. So sometimes it's good if you still struggle with it, go first to the ordinary textbook or the ordinary videos and then go to the AS level so that you make sure your base is very solid. Okay, and then they just give you the values and they got that, the answer. And again, they show you where they gave you the mark. So 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. And at the end, it added up to 6 marks. As your final exams approach,
I want to highlight the importance of the y equals mx+c mathematics textbooks. If you don't have them yet, you can find them at the following bookshops. These textbooks will be your reliable study companions, guiding you towards mathematical success. For educators aiming for exceptional maths exam results, start using the y equals mx+c mathematics textbooks used by leading schools in your classroom. They are part of the NEET catalogue and can be easily obtained within your ministry's textbook budget. Make sure to communicate your request to your region's procurement department to empower your learners with the best educational resources. Furthermore, schools have the option to place direct orders with us, and we offer bulk order discounts. Reach out to us via email at the address below. Best of luck in your maths journey.